How is everyone doing? We're about to get into some Go. I know, it's not my usual, but we're going to do Go. And we're going to see tonight how it goes. So, what we're going to do is, I haven't actually used generics in Go yet. I know that they've existed in 118. 118, I read about them, I was going to use them, and then I heard about their performance issues, and I didn't use them. And then, let me think. 119, I've heard that their performance has improved, and still haven't used them. And now 120's out, and I'm kind of sitting here like, why haven't I used them yet? I guess I got so accustomed to dealing with Go as Go, I've not actually used them. And a lot of the stuff that I do is a small microservice where you're not really doing, you know, any type of generic in general. It's not where they really shine. Just small functions here and there. So anyways, let me pull up chat really quickly so I can keep an eye on it. And then we'll get started. All right, another thing that I thought would be fun. I don't know if anyone has ever done this, but I play with this every once in a while when I think that I'm better than I am. And oh no, one second, my desktop. What's wrong? What's wrong? There we go. So basically, one of the things I thought would be interesting is this breaks down. Maybe I should be. Wait! Don't do that! Don't do that! There we go. So basically, this breaks down your application into the machine code that it's getting compiled down to. Whether you can read this or not, that's beyond the point, but you can kind of see how performant your application is going to be based off of, if you wanted to generically say the amount of machine code that's made. That's not always true depending on what actions it's actually doing here, but it can give you a pretty easy go to, like, oh wow, this was a lot of code versus a small amount. And so I thought it would be cool to see the generic form of a class or a function, a struct, versus the non-generic, and see if it's a lot more code or not so much. I thought that would be one interesting thing to do here. Yeah. So I have this. We have some Go code going. So I guess we should write a generic, I guess. Um, let's do that. Let's do that. Let's just start with a generic function, I think. So we'll just do what should be a good generic function. I think we could do like comparable. So we could do something like func. Let's see. Is greater. And then, so Go does this a little bit differently. You can do this, and you can do we'll just do t and we'll do comparable. So actually, yeah, I mean, this is probably not the uh best use of a generic here. Coming up with something off the top of my, I should have thought about this ahead of time, and we're just going to return We're just going to return a bool. I think that will be... Oh, I didn't make the function name. Or I didn't make the the function call. My bad. I was like, what is it complaining about? I made it. I made it. So this is going to be like A, B, and they're both going to be of type T. Cool, cool, cool. And then we're going to return A equals B. All right. So I think this works. Again, I've never actually used them, so and I said is greater, is same. Maybe is a better word there. All right. Oh man, I keep going back and forth to like Rust. I almost did let here. I've been doing a decent amount of Rust. So we'll do just whatever. T is equal to is same. Now, to call this function, do we actually have to give it the... We don't have to actually give it this, right? We shouldn't, right? It should just be like... Okay, and then we'll just print this off. Okay. I don't know why... Actually, you know what we don't have? I think I disabled all of our smart bots. So that would be a good thing to see is if they handle the generics. We'll do Copilot in just a second. See how well they do that. Let's just run this. Our same is false. And they're the same. Okay, cool. Kind of worked. I think that it's a little weird that they did it with not angle brackets and square brackets. I think it's fine. I haven't looked at the discussions behind this because my general thought, and like I've complained about this with Rust, don't be different to be different. Like one of the things that I hate about Rust is their little pointer to a return type. Why? All at best you make things more confusing and makes it harder to go between languages. I feel like not a real reason to do that. Okay, so this worked. And we should be able to update this and do... Right? And it's a generic. Now, I believe this should fail. Yep. Cool. Yeah, it's not an inferred type. Okay, so that's nice, but we should be able to update this to be... no, yeah. Okay, so this is what I would expect. Cool. All right. I know that's what I was that's what I was just saying is like I really wish that like now I wasn't a part of all of the conversations and I didn't read everything about it. You know, maybe they had some reason not to do this right here. And, then fine. But sometimes I feel like they do this just because like they wanted to be different. And it's like, okay, but now I have to remember square braces and whatever. But all right, this worked. What I'd like to do actually now is write this same function as a non-generic for just an integer. And you know that will take a b int beautiful bool. I realize this is a dumb a dumb function. I get it. I'm just testing some stuff. But all right, so obviously this is going to work. But what I wanted to see is I have not done this for a while, but what I'd like to do is use this here. And basically try to see the difference here. So this right here generates this code right here. And then I want to see like calling it if that makes a big difference here. Wait. That shouldn't have failed. Did I misspell this? That's what I have here. That shouldn't fail. This is valid. Output icon. What's an output icon? A declared but not used. That's literally okay. This should not be. This should not be a build failure. That annoys me. I actually want to use A because I don't want it to get optimized out in any way. So let me rephrase this to be fmt dot. Oh, yeah. That was probably slower than just typing it out. Probably. Come on. Come on. Oh, wait. I didn't capitalize this. And I did capitalize this here. I did. Okay. This is the interesting part, is like actually calling this causes a lot of stuff to happen. So the function here is relatively small. Basically, this is the function data here, and then we have the actual this part, which is just returning these two. It's amazing. Now, I actually really love this tool. If you haven't ever used it, it's called Godbolt. The really cool thing you can do is you can check different compilers, so we can actually go to Wasm, or like what I like to do is ARM, and see the difference here. You can see that there's actually a decent amount more instruction. There's 120 instructions on the ARM, and then I guess it's exactly the same on the 119. Exactly the same. That's actually interesting. All right, so we have a baseline for our. Now, this doesn't have 120, but we have a baseline of 120 lines for our things. We're not going to look at exactly all the things that it does, but now what I want to do is make this is same int a generic and see if that changes a whole lot. I'm just going to copy and paste this. And this is going to be just is same. It's only like it was 120, so it's 7 more instructions. Now, I think I have something that is going to be interesting here. If we look at the function here, let's see where that is. The function is the exact same amount. Now, what I want to do is b is going to equal is same with a string. So, oh, and b is not used. A is quite a bit more at this point. So basically, this line took us from 127 to 202. Very interesting. So we can see this function now has grown. And this is actually kind of the point I was going to try to get at. I didn't realize it was going to be this good. So this is how they implemented generics. Now, growing in compiled code doesn't actually mean anything because you can do this with Rust, and this is actually an interesting thing to do with Rust as well. Rust actually makes a distinct copy of everything that, so if you do this with an int, it's going to make it's going to make basically this right here. It's going to make a func is same int. Obviously, Rust would do the underscore of a b int. And then if you had and it's going to do, just this right here. And then if you also did it with a string, it's going to do a function is same string. Basically, what it does is it makes a individual. Now, if you're familiar with like C++, C++ templates do this as well, but you can do like their dynamic ones, which use the VLOOKUP table, and that's a lot closer to how Go is doing it. But they're kind of doing a hybrid approach because they're like doing they're doing like a hybrid approach. I read for like 30 minutes today on it to kind of refresh my memory. Yeah, let's actually do that. That's actually a perfect one. That's a perfect yeah. We'll remove this altogether. But boom. That's an is same int, and this is an is same string. Now, what I want to do next is actually benchmark this. We can do a Go benchmark. So this is 189 lines, and then this one 1 second, let's delete this. Oh, I guess I've left this square. 1 second, let's delete the square out of both. Let's make them the exact same. All right. You failed. Why did you fail? Output window. Missing function body. No, you're not. Oh, right here. Yes, you are. You are actually smarter than me. Go output. All right. All right, so this is 181, but if we look at this actual function here, is there a way to reveal linked code? Yeah, here we go. So this is the link code here. And then we'll see the same. This is not the exact same. Oh, this is a string. Interesting that a string would have quite. I guess string would make sense. Okay. String would make sense that it would be a. Maybe we should do it with a different one than a string. Line 11. What about line 11? What are you asking about here in line 11? Does not support function overriding by argument types. Oh, okay. Yeah. So, as far as amount of code, which isn't necessarily, because again, like Rust is going to generate one for all of them. So like there might be more code generated with there. 181 and 194. So this does generate a small amount of code. I don't think that's indicative of a performance cost though. I would be standard, and they do actually, like I said, they do a hybrid approach, so I would expect them to have more generated code in the end. It's when you get into like the function shapes that it's very interesting. So let's actually try to test this. I haven't written a performance test in Go for a little while, and by a little while I mean maybe years. So we're going to do new file, main test.go, just like that. And then we'll just do what? We'll do package main, import testing, testing. And then we're going to do all right. Hey, that's actually pretty cool that it knew that this was how to make a benchmark test. Okay, that's actually pretty awesome. So we want to test generic is same. Cool. We just called it is same. And then we're going to just do a for I is equal to 0. How are you doing tonight, Russell? I is less than 1,000, 10,000, 10,000. I plus plus. Should I generate something or just I'm just gonna pass it. This is okay. This is a little weird. It keeps wanting to put these square brackets here. I don't want them. Okay, we're just gonna do 1 and 1, and then we're gonna run this benchmark. That ran insanely too fast. We're gonna have to bump this up one more number. Holy Toledo. It's taken. This is in nanoseconds an operation here. Oh gosh. All right. Let's add a few more there. That was maybe a mistake. I added quite a few zeros. So we're up to 2.4 seconds. Okay. 2.4 seconds. So let's see if that's reliable. This is obviously not perfect. 2.5 seconds. Now I'm not running the encoders on this machine. Did you know that the James Webb Telescope? Are you Google's AI? Are you Google's AI? Because I feel like this is something it would tell me. Do you know what the best part about Google's AI was? It was recorded. This was not a live demo. No, 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 no. This was a marketing video that they didn't fact check. They didn't fact check their I cannot somebody I believe lost their job. I believe somebody lost their job. Like, if it's live, this is why you don't do these things live. Ask Microsoft about Tay. All right, so about 2.5 seconds. Now let's do this again. We're just going to copy and paste this bad boy. And do I still have the... yeah, I do have the same int. I was going to say, you can find the internet of ChatGPT being wrong. They didn't get so much negative publicity, though, because, like... I'm sorry, it was just pretty bad. 2.45. The other one was like 2.5 most of the time, 2.5 seconds. So this is 2.5. This is roughly the same. Yeah. I'm going to say this is the exact same. I actually feel like it's just a touch faster. We're actually hitting under 2.5 more often, but well, actually that one's almost 2.6, so we're in the so close it doesn't matter. I mean, it's going to be hiccups on my computer. Right, AIs make mistakes. People know this. Just don't advertise that in your answer to the market on what you're going to do. Right, that was like the big blunder. Is like, again, I don't know that anybody wouldn't have expected a mistake like that. It's just that was your marketing video. Okay, so this is working pretty well. Let's write something that's not just a function. Let's write a generic struct. Can we do that? Okay, so what am I going to do? I'm going to do like a point. I really should have thought about this a little bit ahead of time, but we're just going to do, yeah. Those benchmark, I don't know if they're doing cache warmups. I'm not that big into Go benchmarking, so like, this is something that I would like to explore some, though. I mean, we should definitely look into it. That's what this time is for, is exploring and understanding. I'm sure that there's more packages that can do more advanced. I just know that it is built into Go Test. Like, this is a legitimate thing that you can do. And that's the most I have ever done. So you're pushing my knowledge of performance. So like, yeah. All right, so let's see. We're going to make this a type of, I was going to say point, but not really point. We're just going to call it Randy. I'm sure Go has a benchmarking library. I'm sure of it. I don't know it. All right, we have a type Randy. We're going to say that it can be of type T, of course. And I guess we'll just say that this can be Annie. And this is a struct, of course. Oh, you know what the other thing I wanted to do is I wanted to turn on I wanted to turn on Tab9 or the VS Code one, the Microsoft one. What is it called? Code Whisperer. What the crap is it called? Copilot. Where is it? It's not enabled right now. All right. Enable. There we go. I actually have to turn Copilot off when I'm doing like the Rust classes because it starts to like try to do all this guessing and it looks really unclean. That's another project that I'd like to write sometime today or sometime this year. I want to be able to animate code being written. So like so in my videos, like I'm just now like cutting out the code being typed, but I'd like a really clean, fast animation. I feel like maybe we can code something up to do that. I don't know yet. That's like way later. At some point, I actually thought it would actually be easier in Vim. We could do like a NeoVim plugin and have it typed out in NeoVim. I feel like that wouldn't actually be that hard. Not entirely sure, but I feel like I have a good feeling. Okay, let's see. We have Randy here. Randy is going to have stuff in it, right? It's going to have A and B, and they're going to be of type T. Okay, I'm super original here. We're gonna leave those. Let's see. Okay, let's make a function. Let's make a function. Okay, so this is actually really good of Copilot. It knows this. One thing that people don't do is you have to put this in the function. So if you're making a function on Randy, Randy needs to have this in there. And if you're not using it, so like you're not using the type T in here, so you could say is same as, you know, B of type T. This would be fine. But if you're not, and let's say it's just like, let's say this. We're going to call this get A. And so this is going to return type T here. Yeah. Now, but let's say we made a function like this. Func Randy. Okay, well, we'll get B. We'll finish this out because Copilot really wanted to. But the example I was going to show you is not is same. Let's say is valid. And let's say you don't need the type at all. You can do that. This will compile. This will compile. Let's actually just, you know, don't take my word for it. Let's run it. Compiles. This will not compile. Oh, that did compile. It shouldn't. Oh, I didn't save it. I didn't save it. This won't compile. Yeah, it won't compile. This won't compile. So I know that you don't use the generic in this function at all. And I know that I'm being a little didactic here for somebody that doesn't use Go generics, and so I know not much more than what I'm showing you. You have to put this in here. Whether you like it or hate it, this is fine now. Let's see. You said that there has to be a Go benchmarking. Let's look at it. Go benchmarking tool. This is just like benchmark. This is Go by example. They're not library. This is just benchmarking. I don't know. I'm sure that there. This is the Golang benchmark project. I'm sure that there's one. 1 second. When all else fails, we'll ask ChatGPT. 1 second. 1 second. Oh, wait. Is the free one gone now? I thought there was still a free one. Oh, it's at capacity. Okay. I got it. It's at capacity. They want me to pay. They were at capacity. Not anymore. Not anymore. All right. Oh, what are we doing? Oh, best go benchmarking library. The BET library for benchmarking does not seem to be a commonly used or well-known library. I could not find any information about a library named BET. I didn't ask you about it. Oh, I said BET library. Oh. I actually did screw that up. Okay, sorry. Best go benchmarking library. So it seems ChatGPT agrees with Google in this case. This is wrong. I think this is wrong. I think this won't work. Let me try it. I think that will be wrong. Okay. I always thought it was equals period. So it doesn't matter. It doesn't matter. I always did it with equals. Perfect. Not wrong. Like I said, ChatGPT has your back. Every single time I call it wrong, it's not. What other options are there? XX hash. This is a family friendly stream. We can't open that one. I'm going to throw these into chat. That's the one that was already. This is the above one. I also don't know what this one is, this XX hash. Oh. Let's see. XX hash is a Go implementation of the XX hash algorithm. It's yeah, okay. How is in addition to this isn't a benchmarking library. It's a hashing algorithm. Thank you, ChatGPT. Thank you. In addition to the standard testing and this web framework that I found, there's some other benchmarking, like the benchmarking one I talked about previously. All right, let's look at this one. All right, this one looks acceptable. This looks acceptable. The last two of the three. Okay, let me see. Oh boy. it's so confident in its. You know what would be great? You know what would be great is if this is actually a private repo that it got access to somehow. It's just putting stuff out there. Like we said, it wasn't so bad, except it was marketing material, Google. Marketing material. All right. Let's get back to our regularly scheduled program. We were doing this here. Not this. Not this. We were doing this. We did Randy. We did. We don't need this is same anymore. Delete that. We have Randy. We have get A, get B. That's beautiful. And then we can up here make a Randy. And do something with it. Let's make a Randy. R for Randy equals a Randy it. Now, 1 second. Do we have to have this? I feel like the answer should be no. I'm going to delete it. Randy should just be typed off of what I gave it to it, right? So we do have to tell it. We have to specifically tell it that these are ints. We're just going to do r dot get a. Randy's A is. All right. So what I'd like to do here now that we've done this benchmarking, is, and I think this is where, if I understood everything about the generics implementation, the function calls on this is where it could start getting expensive. So if we do R, and then we'll do an RS, which is for Randy string, we'll do a, wow, it knew I wanted it to be a string. I'm impressed. Okay, and then we'll do, nice. Okay, thank you. Now let's run this. Let's make sure it works. Now what I'd like to do is compile this into a function that we can test the performance of to see if there's a big difference. We'll make a non-generic Randy. Randy is so generic. Actually, Bob is like the generic name in the US. So let's redo this. Let's make this Bob. Since Bob is... And now we need something not generic. We'll make a Merrick. Merrick is not generic. That's right. Let's test Bob function calls. Whoa, 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 whoa. Why did it square brace on me? That's not what I wanted. All right. Let's see. No, we'll do an int with, yep, 1 and 2. Beautiful. We'll do I don't know what we'll do with, you know what? We'll do RA equals, oh yeah. Good, good, good. RB is equal to get B. And then we'll just make up, you know what, we'll just underscore these. Hopefully they don't get like optimized out. Oh, they just want me to just make it. I don't want to make it just an underscore. So we'll go ahead and print. No, I don't want to print because I want to call this function in the performance test, and I don't want a print line in that. So how do we do this? Um. Uh. Actually, we'll just make another Bob. Um. B equals. We do have to make one of of strings, and now we'll make. Let's see. RR is equal to. Oh no. What is it doing here? It's making a new Bob with the type of Bob int with oh, oh, I like this. I like this. Yeah, let's do that. And BB is going to be the same. Yeah. Okay, I like that. Now we still have to use all of these things. Ugh. Oh, I didn't know Randy had something weird in the UK. Randy is just kind of a generic name. So is Bob. That's all I was going for, is a very generic name, not highly specialized. Yeah, I mean it's just a name here. It's interesting here in the US. I think that we have like a really large set of names just because of like names coming from everywhere. You can find somebody's name. So yeah. Anyways, yep. Randy, I don't need to know what the UK thinks it is. Okay, how do I use all of these in a way that doesn't affect performance and in any way? Wait. I used B here, and I used R here. So now I need to use RA. Actually, what we can do here is we can just make this a new Bob, right? No, yeah, Bob. And we're just going to do this with RA and RB. Done. Nice. And then this one is going to. This one's going to be a new Bob string. Nice. Did it. I just had to think about it for a second. All right, so this. Oh, wait. There's an error. Oh, we need another curly brace, right? Yeah. Uh-oh. Okay, we don't use RR. I'm going to just underscore this. I'm done. Got to underscore. Just got to underscore. There we go. Let's see. What is wrong here? No new variable on left side of O. Okay. And then what we're going to do is this. There we go. Okay. There we go. There's our performance function. We're going to call that a couple thousand times and see how it does. Now we have to also make a struct for Merrick, a highly specialized implementation. Type Merrick. Not many of us, not a generic at all. And it's going to be an ABINT. And we're basically going to do the same thing as this here. Test Merrick function. But we're just going to do this with Merricks. not Bob's. This one doesn't work. We'll have to just make it an integer. What have I done? Oh, this final thing here, this is just impossible with Merrick. There is no comparison. Should we remove it? Is this not quite a fair test? Not fair, but I don't care. It's not fair at all. We'll remove it if it's looking like really bad, and then we'll go back and mutate it a little bit because this is not fair test at all. This one will just be this right here. Whoopsie. Oh, I don't have these functions on Merrick. Okay, let's do that really quickly. Hey, whoever just joined, welcome. We're playing around with Go, and we're testing out the generics. We're getting a feel for them. We are that's pretty much what we're doing right now. And having some fun while we're doing it. We're also decompiling them, checking out what they compile to. You know what? I'd like to do a little bit more of that in the future, just to understand decompiled code and machine language just a little bit better. I think it can really give us some insights, and yeah. Welcome. All right. So this is effectively the same, minus this right here. So let's write some tests for this. All right. Is benchmark Bob. And in here, we're not going to call this many times since we're doing some stuff. We'll start a little bit smaller. And we made a test Bob function calls, and it requires nothing. So basically, I just want to see on generics if that function call mapping really has much of a cost. Because again, there's actually this I have it up in my research. Let me pull it up for you guys. And actually, I'll post this in the it's the GC shape stenciling. So I need to read it, and once I understand this GC shape stenciling, I'm gonna make a video on it because 99% of the work is going to go into understanding it, and then the video will be easy. But basically, this is how it's doing generics, and I understand it generally, but not well enough to make a video. Plus, I think it needs some animation. So, anyways, let's run this test. We need to make a Merrick test function test Merrick. I love. I actually really love Copilot. It's by far my favorite one. Tab 9 is fine, but you pay more for it, and it doesn't do nearly as well. Amazon Code Whisperer has really given me garbage results. Copilot seems to do really well. Should you use b.in for the loop guard? I don't know what you're talking about here. Oh, here? I don't know. Maybe. Wait. Oh. I removed these. These functions no longer exist. They're dead to us. Oh, we can run more cycles. Let's up that. That's taking way too slow. Oh no. Yep. I shouldn't have deleted so many. It has to be long enough because if it's too short, it's too hard to actually tell if there was. Okay. we're not gonna go up one whole one more. We're just gonna go one more, half of one up. There we go. All right, this should be good. I feel like 2 seconds is roughly long enough. Motion canvas. Russell, it's like you know me. And it's like, what could I find that Merrick really sucks at? CSS and TypeScript. Oh, wait. No, this is not the CSS. Oh, actually, this is a different thing. Motion Canvas is actually cool, but it hasn't been released yet, has it? Oh, wait, it has. Last I looked, it wasn't. So this guy actually makes devlogs. The guy that makes this right here, Motion Canvas, what you sent. The guy that made this actually makes devlogs. He's making like a game. And I saw it because he has like really. I watch the most amount of YouTube I watch is other tech YouTubers and trying to understand how I can be a better tech YouTuber. And this guy makes some really cool videos graphically, and he made this. But I'd been watching it for a while and it hadn't come out. But it is still TypeScript. I suck at TypeScript. There's another one like this that is TypeScript and CSS, and that one I suck at. I'll have to try this. They made about 5 videos with it. I'll have to try it because I really want to add, like, to be honest, one of the things that I think my YouTube videos lack the most is good animation. I mean, like, I don't have the skill, and I don't have the time to really develop it really well. And so, like, it is hurting me. It is hurting me. And I don't have the money to pay somebody. So. All right. So we have a pretty good benchmark here. This one's taking about 11 seconds. I know this isn't perfect. This is not a perfect test. We'll drop this in the decompiler in a second and see what it looks like. 11.2 to 11.5 is what I think I've been seeing. $11.2. One more run for good lucks. You know what I'd like to see, actually. Let's drop top over here. We're gonna run this one more time. 11.2. It's really hitting 11.2. It's hitting a couple cores, but it's not like super threaded here. I'm seeing what, 3 threads? Huh. Oops. All right. Let's get back to this and let's run this one. Okay. I think it's going to be really, really close. I don't think this is going to make any difference. $11.2. Were the performance gains in Go 119 and 120 like that's it? Because I know some people were really complaining about it being like 40% slower, and I don't know, maybe there's just a use case that it is 40% slower in. But as far as I can see here, there's nothing that would say that this is any slower at all. And I don't even think this was a fair fight. This one, the Bob function, actually has a little bit more of a complicated one. It's almost faster. I mean, none of this is any different for me to really say. 11.2 is about the one. Absolutely. And I am doing this for fun. And there is definitely some really good benchmarking, and I wanted to see if there was like this wild performance, because if one function had taken 11 seconds and the other one took 20 seconds, we could, or even 15 seconds, we could look at that and say, hey, this, because this is actually pretty repeatable. We're talking to 0.3 seconds of repeatability here. But when it's this close, it just doesn't matter. Like it means that it's effectively the same, and it doesn't matter. But this was a fun experiment, or at least I'm having fun. I wanted to play around with Go and Go generics. I haven't used them yet, but I think this probably says that they're good enough at this point to use. The last thing I wanted to do with this was to actually take these and put them back in the decompiler, just to see what it looks like. And we'll do the side by side. Actually, let's get that set up now. We'll do this one over here. We're actually going to just... Is that too squashed? I don't think it is, because I'll make the code really small. There we go. Code really small. Well, we'll make the code really big first, and when we get the code, I'll copy and paste it in. We'll make it small. What if it's smart enough to reuse the results? I think if you're telling me that the special built-in benchmarking keyword and benchmarking was caching and reusing, it's failing at its job. That would, like, I'm not trying to be super harsh, but at the same time, if your job is to benchmark and see how it's performing, and you're caching so that you get different, values from the first time to the second time you're running, that would be horrifying to me. That would be horrifying. Okay. Sorry, I thought you were asking if like the Go library was, but you're talking about the CPU cache and bench. I'm running on AMD. They don't do any predictive. I know that they do. Um, Man, I am loving this AMD CPU. By the way, this Ryzen 9. Ugh, it is beautiful. I know that they're coming out with a 3D cache. I'm not even upset. I was on a dual core i7 that was 8 years old before this. So like this is just phenomenal. Just phenomenal. Okay, let's get back to copying these over. Let's get back to copying these over. I don't... You're probably right that the CPU cache and branch prediction could be optimizing these. You're right. If we were going to do a better test, and I just don't have the time tonight to do a better test, there needs to be some random values. There needs to be some jitter put in, and the test should probably run for an hour. Like that's what we should shoot for. Again, this was just to see if there was any major differences. Yeah, I don't think the AMD X models usually do, but I'm talking the X came out, but they're going to come out with the 3D V cache. Those should have the same number of cores. Um, so like, but those haven't come out yet. Usually it's like their midway upgrade is like we released the three. At least that was how they did last ones. Um, was halfway through they released their 3D V cache and got performance gains. Um, okay, so is there anything else we wanted to do with this right now? I think we played around with it. We even made a bob that had the type of bob string, which I think is pretty cool. It supports everything that I can think of. Not that I do this very often. I try to not nest as much as I can. Um, is there anything other than that? And then we can post these in. You know, Russell, I could be wrong. I could be wrong. I'm not huge into hardware. Pass in one arg and use the loop counter. Where are you talking about doing that? Oh, okay. I get it. I get it. I get it. Yeah, let's do that. I think the branch could still get that. Let's do that as we'll do this. There might be a better way. We might be able to generate a random seed. So what we can do is we can generate a random array of numbers in like a pre-step, and then use that array of numbers. That's actually, this is probably better to get around the CPU prediction. So all right. That is better at least. We can throw I in here. Exact same amount of time. Wait, which one did I run? Okay, I'm going to run Merrick. Then we'll run Bob. I can't remember which one I ran. 11.2 to 11.9. I doubt this has any change. 11.2, yeah. I feel like branch protection is or prediction is going to nail this since it's just incrementing. I feel like we need to get a random number, which I haven't done in Go in a very long time. So let me Google that really quickly. A random list. A random array. Okay. We'll just do this. I think if you're really wanting, now this doesn't perfectly get rid of branch protection or prediction. I don't know why I branch protection. I say that so much with GitHub. Uh, yeah. is generating this array the best way to do it? Well, I'm also just going to do this. This might be nasty, but I'm just going to generate this array in an init. I actually really hate inits. I hate that people use them. Yeah. And now I'm using them. Such a hypocrite. Let's see. We need to also math rand. There we go. Beautiful. We're gonna rand that seed. Rand that seed. That sounds. And then let's see. Rand dot. Okay. Cool. 10. How many do we want? I don't know. That number, whatever that number is. That. It's a good number. Let's see. It is 1, 2, 3, 500 million. And so this should be a. Wait. I thought this was an array. Returns as an int, a non-negative pseudo-random number in half-open interval. Wait, I thought this was returning an array. It's just returning an int? That's not what I wanted. Oh, wait. No, I didn't do. I think this is what, I think this is what, Copilot was recommending. Okay. This is what I want. Yeah, returns a slice of ints. Okay. It's fine if it's just pseudo-random. Invalid operation cannot index B, variable type. Oh, wait. What is this returning? Just a slice. Why can't I? Oh, wait. Oh, B is over. Blah. There we go. Rand slice declared and not used. Oh, I did just, okay, let's see. This is a slice of ints here, so. I don't think that we actually need to make this. We just need it to be a type of int. There we go. What is it not expected? Oh, var. There we go. Rand slice declared and not used. I'm using it right here, buddy. I don't use init very often at all, but I thought this is how you used it. Declared it. I said it. I used it. Where do you want? What more do you want? Did I misspell it? I didn't misspell it. It even knows that it's an int. 1 second. Do I just need to run this? One second. That doesn't stack up. Oh, this isn't the test. So I guess it would only fail if you were trying to run a test. So let's try that. There we go. It doesn't like this init function. I could be very wrong. I don't use Go's init functions. Go init function. I thought that that's how you could use it, but I obviously am wrong. I thought I knew Go pretty well. Var name string, name equals this, print out name. This is literally how I'm using it. Is it just in Go testing that this doesn't work? Because this function in it should be called for the package. What I could do is throw this over in main. Actually, let me just get all of this. Like, maybe it doesn't like being here. Maybe it would prefer it being over here. Again, declared and not used. Oh, you know what? I know what it is. I know what it is. In standard builds, benchmarks aren't used. So it needs to be used in the actual code for it to be valid. I think this is what we're going with. Okay, so let's actually just use it here. Let's just use it here. We're just gonna print one from RandSlice. There we go. It's still saying it's declared and not used. What am I missing? Well, apparently I barely know Go at all. Apparently. That's what Go is telling me right now, is that I don't know it. It seems fine here. Okay, yeah, we can just use it in the init. Oh, I'm an idiot. I'm an idiot. This isn't the problem here. What the problem is, I did this. I wasn't assigning this one. I was making a new variable. I was shadowing it, a thing that I hate with Go. So I was shadowing this one. This one wasn't getting used because I was stomping on it. So this one was never getting assigned, but it was getting used here, so it wasn't complaining. Oh my gosh. Now, I might have not been able to use it in the Go in the test package anyways, because that's just how Go doesn't compile this. It's like if I only ever used it in a Rust module testing package. It's outside of it. So, all right. Anyways, I'm an idiot. We're good. This. So the only reason I wanted to do this in init was I didn't want it to run on each iteration. I wanted it to just run once. There we go. I'm guessing exact same. I don't know that this would get past the predictive branching. obviously it got past the predictive branching because this took so much longer. Now, you know what I don't know is how long this took. How long did this take to run? Because that's going to run beforehand. So honestly, I say it obviously got past the predictive branching. I need to actually do this as a test. I don't know how long that takes. Do you know what? This just needs to have nothing because init's going to run anyways. So let's just run this as that. This should tell us how long it takes to initialize. It's taken a little while to initialize. I'm going to guess around 15 seconds or 19 seconds. So, yep. And so our 11 seconds that we were taking is still what we're taking. So, yeah. We're doing this one more time. Guessing 20 seconds again, or 19 seconds again. Then we'll run one with benchmarking Bob. Yep, we're at 20 seconds. All right, let's see how this one does. You did guess closer. You win the prize. You win the prize. We did try. This was good, and I'm an idiot. This mistake was unforgivable. I've been doing too much Rust lately. I didn't even think about it. Wait. This one ran in 30 seconds? That had to be a hiccup. I'm running it again. Is Bob more efficient? Or did we just have like a really bad initialize on the test Merrick? Or no, it was running in 30 seconds. I don't know. I was thinking 50 for some reason, but it's running around 30 seconds. Never mind. They're the exact same. Okay. Yep. Good enough. Let's get back to copying this over. What did we get over so far? We have the generic. We have this. Looking good. Now, we need to update our main function to not have is same. And now we need to use Bob. We're going to just do this right here and this. And then we're going to say A is RA and RB. But boom. Type Bob int. Oh, this is an error here. We're gonna do 1 and 5. Boom. Cool. Now we're gonna move that over and we're gonna look at this. As soon as I get this all worked out. Okay. We're just gonna do the exact same here. Instead of a Bob, we're doing a Merrick. Merricks are highly specialized. Cool. So we have about 338 lines of code for Bob. And we have 200 for Merrick. So a lot smaller. Another thing that I would like to see here, which I actually think this is good. Again, it means that they're generating code, which usually means longer compile times, which is why some people don't like it. But it means faster performance at runtime. One thing that we can do here, just to see how much extra code gets compiled, is this is only going to compile per thing that it needs. And so if we add our string that's a Bob string, it's going to have to compile out, generate code for another one, or at least partially. Oh, I tried. I tried to do that all. RS equals Bob type of string A and B that looks snazzy. And then I used it. What's the compiler output saying? Unexpected RS and argument. Missing a comma. Oh, I missed a comma? Really? That sounds like me. There we go. I can at least see now. All right, where did I miss a comma? I have a comma there. Oh, I'm missing a comma here. Huh. Now, since I was doing all that, the generic ran. It seems like the generic runs actually just slightly faster than the highly specialized, like a second over the 30 seconds. It was generically like 1 second faster. The comma was on line 26. I got it. And now, what the garbage? We're up to 715 lines. 715 by just adding this. At first I should have added this here. And now what I'm going to do is I'm going to delete this. It was 715. And this is, let's get it to recompile. 338. 338. That's awesome. That's awesome. I want to understand this better. I want to understand these better. Ooh, another thing that we could look at here. Let me actually make this bigger. So we add this. Yeah. And we explode to 717. Do we think ARM... Now, Go doesn't support ARM as well. Do we think that's what it's going to do? I don't know. I'm going to find out, though. ARM 64, 119. Ho, 717. Nice. This does not mean performance will be the same. Again, like I said, it's subjective with how many lines of code. Actually, I would say that if you're comparing language to language, so if we compared, this right here, this very straight one with Go and then with Rust, I think that's a very pretty much like the more lines of code executed here, the less efficient that one is. So you're going to see more here with Go because Go has all their garbage collector bundled into the binary. This is pretty large. The equivalent of this in Rust is way smaller. I say that, don't take my word for it. And that means it actually is faster. But you can't say the same here with the generic code because it's compiling copies of code out. Now, this is actually more than I expected, to be honest. More than I expected. One second, here's risk. They're all the exact same. That actually surprises me a little bit, but we didn't do anything with threads or anything where different platforms really stand out as being different. So maybe it doesn't surprise me. I can actually do that if you guys would want. We can go and see. We can recreate this as a Rust thing, and we can see how many lines it creates, and that's roughly indicative of the performance that you're going to see. Right, and that's actually what you're going to see is here in this code. Check out how much code was generated in this Go, and that's because you have stuff for garbage collection. If you look at this function is very little data, very little data. It's just this. Even this is more overhead than what you're going to see in Rust. I'm pretty sure. This is the other. You're just really moving one registry and returning. Super simple. This main here. The one thing that might be interesting is like the print lines for the macros. Those are actually generated code, which is kind of cool. Let's actually bust this out in Rust. Should we do, well, we didn't do, this one is just ints. We can keep it simple and just do ints. No, I'm not doing it in COBOL. Anathema points for you. Anathema points. All right, let's see. Let's delete that. That's garbage. What are we doing? We're making a struct. We're calling it Merrick just to keep it the same. And this has an A int, right? An A int, and it has a B int. Yeah. COBOL. And B int. Okay, good. Wait, why does it not like these? Oh, I said int. I'm sorry. I'm in Go I32s. These are going to be I32s. I was like, why does it not like these? Because they don't exist. I'm doing I32 because these are going to be I32s, right? Actually, these are probably platform dependent. Might be I64s. I think they're I32s though, but I'm just going off of gut feeling. Parsint always returns an int64 because yeah, they do have like there is an int64. So that's why I feel like is a signed integer type that is at least 30. I think it's architecture specific. So kind of like the U size. Um, so yeah, I'll just use I32s, not U32s. Although I guess really I size would be probably the closest thing. Okay. Pub fun main. That's what we did over here, right? Oh. It's so fun to type fun, though. Okay, so when I'm switching between languages, give me a small break. We're going from funk to fun to FN. Give me a break. Give me a break. Okay, so then all we do here is this right here. I'm just going to copy and paste this over and translate. We'll need to make an implementation. So we'll do that. There is a language. It's a Java-based language, Kotlin. Kotlin uses the word fun to make the language more fun to write, I guess. You know, because they're so upset that they're in a Java-based language, they had to spruce it up a little. That's my thought, at least. So, okay, so this is total garbage. Let's actually get this working here. So we need to do an impl here. Man, I really don't like typing without code complete. I make so many mistakes. And what functions did we have here? We had a get B and a get A. That would probably be a little bit better if I just typed it up really quickly in, let's see, open a folder. Thank you for putting it behind Visual Studio Code. I don't need an. Actually, I'll do a new. That's nice. Actually, I won't do a new because that will count against us in our comparison. New's nice to use, I know. But we're just going to do get A. And then we're going to do a get B. Right. It's going to be extra instructions. So we'll delete it. We'll delete it because it's not what we want at all. And then no, stop trying to make me do that one. There we go. All right. And then what did we have over here in the we created one, we called get on it, and then we printed it out. Okay, so we okay. But here we're going to actually do assignments, so we'll do let B, print line AB. Beautiful. So much faster. And then we just, nope, I went to the wrong one. This one. Then we're just going to pop this in like this. Oh, we need the implementation here. We're going to pop that in right here. Boom, like that. All right. Who has the fewer instructions? Look how clean this is. Just appreciate how clean this is here. And when we look over at the like garbage collector, blah. $201, $142. Oh, yeah, it did. But also, this is just way cleaner. So this is interesting. This is the print line. The print line here is way more than any of the other stuff. Like, okay, this is our get A. This is our get B. Let's flip back over here. We'll do our let's see, reveal link code. Here we go. This is our get A, our get B, and get A up here. So these functions contain, let's see, 15 lines, versus over here they contain 1, 2, 3, 4. 15 to 4. And this is where I was saying you can use this to compare performance to a certain amount. Now, obviously, when you're talking about generics and the one was generating a bunch of different distinct code, it throws it completely out, because obviously if we did a generic in here as well, we would see the same thing, because that's what Rust does to get the zero cost, is it actually generates a distinct different struct for every single one of them. And that's pretty cool. It's pretty cool. This is so much cleaner. I wonder what these are. This almost feels like FMT stuff. It almost seems like this up here isn't even part of our application. Just this is almost them supporting Rust. And this is all our application is right here from pretty much 70 on. And then this just looks like debug symbols, like this had invalid args or things like that. Whereas all of this ties back to our application somewhere. Okay, maybe not some of this. Right, because we actually have a garbage collector compiled into here as well. $185. Oh, wait 1 second. Sorry, let me see what you're saying. Can you see the system call number for print in both object dumps? Line 185. There isn't a line 185 on the Rust one. 185. Let's see. 185. Is this what you wanted to see? This isn't a print. This is actually what I love about this tool is you can actually learn some machine from it. It's compares the first source operand with the second source operand and sets the status flags of the E flags register according to the results. The comparison is performed by subtracting the second operand from the first operand and then setting the status flag to the same manner as the sub instruction with an immediate value is used as an operator. Oh, my face is covering this, isn't it? Whoop. There we go. There was a line that was doing a call. You are right. Let's jump to where this is going. I don't know what these func datas are. They don't happen in Rust. So this is like, I believe this is like the printing out here. I think these calls are the things that are actually printing out to the terminal. So that's this. So this is what's printing out. This is the format. Not scroll you to see that function. I think you are asking to see this function. I can't scroll up. I'm at the top. I wonder what these new display. I mean, I'm guessing this is to do with the terminal. These new displays here. So I mean, all of this code here is for the FMT. If we remove the FMT, I bet you our compiled project goes down by 100 lines of code. Do we want to try that? 1 second. Let's do that. Oh my gosh. Oh my gosh. I called it. I called it. We removed FMT and our program went to 18 lines of code. One line. This stupid line goes to 142. Now, I don't think that will be the same if we remove these two lines here. Go is going to fail. Why are you failing? Oh. All right. Even without FMT, Go is at 79. 79 compared to 1 second. 18. I wonder if the formatting to out. Oh, we can test that. Let's just write. Let's just do a print line. Wait. This is, yeah. my question though is like, is this going to have to do the formatting anyways? It's shorter. It's 105 versus when it was actually formatting. This was longer. 125. So you are right that formatting has. Is that valid? I guess it is, yeah. It's still 105. An empty string or print line. So formatting is about 20 instructions. If we're hyper optimizing, formatting is 20 instructions that we don't need. I'm kind of impressed actually that formatting a string is only 20 instructions. We are at the same with a print line, actually with formatting, we are at the same length as a Go program. Yeah. Ah, 200 glorious lines. Might depend on the number of arguments passed. Let's test that out. Let's do A and then B. Shouldn't 139? Yeah. I think you're right. And then let's do C. Yep. Now, I would expect this to not add any more. Yeah, it doesn't. Okay, that is what I would expect because being able to print 3 is able to print 3 and shouldn't take any more lines to do. The compiler does some wild and sometimes clever and sometimes strange things. Like the other day, I have literally not been able to reproduce how it's like this code might have been inlined out. I have tried. I literally followed my video from the start, typing what I did, and the first error that I got was that it couldn't make an integer out of it because it had a new line. Like I was just like, I'm just gonna follow this, and I cannot reproduce it. That was so frustrating. Anyways, this was fun. This was fun introduction to Go generics. Oh, I was like, this does not look like Go. It's definitely not Go. Let's see. Yeah, GoGen. Go generics faster than playing Ghost. I am not going to push that. It it definitely doesn't seem like it has a penalty though. Not at least for the simple cases. Now, like we didn't do any complicated things here. Like, we didn't even really put constraints on these, and like that, those are some of the things where I just don't know. Like this says any, but I could start to put constraints like comparable. We could start doing some like interfaces and things like that. And I don't know if that is what starts to get it. It starts to like make it slower or whatnot. So there's definitely edge cases we didn't explore tonight. but they're definitely fast enough that I would say, like, I'm not super worried about people using them. You know, when they first came out and there was some people that are like, yeah, this code can run up to 40% slower. I was like, 40% slower is not a, oh, it's almost the same speed but slightly slower. No, 40% is horrifying. And I know that they've made a lot of improvements. So I might go and install some other versions of Go and see. But and yeah, like I said, we didn't do anything super complicated here, but I don't think a lot of people need super complicated generics either. I think light generics. Light generics. Can you see what it's generating? Yeah, I can. In theory. It's generating wait, this is Rust. Where is my It's generating this. Have fun. So this is this code here. So this is actually pretty cool because you can actually see that it's generating two functions here. As we've already proved with Go over here, when we looked here at Go, and let's look at this. So this is actually, I'm getting really excited about it because this is actually kind of interesting. A Go function has this header data. You know, this is like some function data that it's doing. And then this is the actual function here. So, you know, you can see down here, this is the function. That's what the function is doing. This is, you know, that header data for the function. What we can see over here is we actually made two of these. We made not over here, sorry, over here. We actually made two of these. We made an integer and a string version of this. And check it out. We have two versions of this function. We have two versions of this same function. We have the header data here. We have the function. We have the header data here. And we have the function. I think that's like super cool to actually see that. And maybe I should make a video out of this. Like, I don't know that I know this stuff well enough. So maybe I need to phrase it in a way where I was playing around with this. This is pretty cool. But we can see it here too. It generated two versions of the same function. Oh, now put it down to 117 wouldn't work. It was released in 118. But we can release it to 118. So let's jump to reveal linked code. It has two versions, yeah. So I will send you a thing on there. I'll have to find it. Actually, I don't know if it's the same number of lines. Let's check it out. This one has 717, and this one has 500. Not even close. So 118 has to be way slower. And this is where I bet you when people were saying they're 40% slower, and I know, and maybe I need to go review those docs again. I know that they said they made massive improvements in 119. And I even stated that they said that. I just never then gave the generics a chance. I bet you they started generating a bunch more code. Like, I can't explain it any other way. There are 200 lines more code generated from this. Now, what I wonder is, where are those lines of code? So these are the functions. And this is, okay, so this is, oh, okay, look at this. I a little bit better. This is for the integer. So this is Bob for integer and Bob for integer down here. So these are the specializations. Um, there is no link code for the type, which would make sense. Types aren't really a thing for the compiler. Okay, okay. This is just how it's stored in memory. Got it. So what I'm wondering is, I don't know all of these. So like, I don't know what this func data is. And it seems to just be a Go thing. It's not calling a procedure. Oh, check this out. Oh, okay. Huh. This func data, I almost wonder if this is like a function pointer type of thing. Like, look at this. It's referencing Bob int here. So like we could actually follow, like this is this main Bob int. Like this is like the specialization of Bob int, like this right here. I almost think without learning any more, if I just nitpick this and change stuff over here, I could learn at least a little bit of what this is doing. Oh, this is garbage collection, the GC local. Well, it's also GC shaping is one of the things that they used, which I don't think was part of garbage collection. Again, I need to read more on that. I'm not an expert on it. Now I want to go back to 118 and see how this looks different. Wait. So yeah, this is a Bob string here. And so they do some generation here, but this is just less. They don't have... Okay, I actually need to just follow one of these. Okay, so let's look at this one. I'm going to copy this one. And it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It does not exist. Let me genericize that. It's not finding it at all over. Ah, there we go. Is this like Visual Studio Code embedded in here? These are actually kind of completely different. This was main Bob string, and now we have the main Bob int here. But this is like let's see. Let's do underscore Bob int. We might get this here as a hit. All right, so this is close to what I think this is the same function. If you remember, we had this PC underscore PC01, and this is PC21. We don't need to get into that. So I think this is that function that we were looking at. Maybe. I'm not sure. I'd have to do more digging. PC21, let's see. So this is like all the int data. And then let's go back to 119. Holy crap, this is all the int data for 119. So much more generated code. And again, that's where like I know that I said sometimes you can take that what generated and say like, oh, like I did with the Rust. the Rust is more efficient. It generates less instructions to do it. But that's not always true. I think this is a good example of where that's not actually true. Generating the code is actually better than having dynamic things done at compile time. And I think that was what hurt 118 is it didn't generate. I mean, that is what the blog articles are all about, is that it wasn't generating the code. So like it was actually doing dynamic stuff during like VLOOKUP tables during runtime. So anyways, super cool. Super cool. That was fun. I learned something. If it can also use more complex instructions, it should make like I said, it's just a really like if you have a simple function and you use Godbolt and you look at it and one generates 2 pages like Ruby will and one creates 2 lines like the C++ version will, you can generally go and say that will but again, yeah, it's a generalization that holds true for 75% of them, but you can definitely make it wrong as well. Especially with the dynamic stuff. So like when you're talking about VLOOKUP tables and that type of stuff, it's literally basically calling a generic function with like type data and hitting a couple hash maps to like look up the different types and stuff and doing it all dynamically like at the time of call, at the time of execution. It gets really expensive, but it generates less code. So yeah, I find it interesting. I need to get better at looking over this stuff. I need to get better at understanding some of this stuff. I think you're right that this is like garbage collection stuff. We have this call. We can follow that. This is the main function. I do love right here, you can be like, hey, this is our get A. This is our get A function. It's right here. And we can go to this function. It's calling it. I also think people should learn this more than they do. You know, I should know it better than I do. And no, not that we all need to be like low level people, but the better you understand this, the better you can utilize your language. Like I'm going to be able to utilize Go better now. Even though I've written Go for 4 or 5 years, like 4 years, 3.5, almost 4 years. I'll be able to write it better. I at least understand it better, how it's going to work. And I want to actually do this more when we get like an interesting problem, when something's not working quite right. Like what I was thinking, Tuesday's Rust fiasco that I had, I should have started to try to see what it was doing in this and to understand what it was doing better. What does function data mean? That's what I'm doing right now, actually. More than welcome to leave. What does function data mean? It seems to be a Go assembly thing. Ah, you called it, Russell? You called it. The function data and PC data directives contain information used by the garbage collector. They are introduced by the compiler. This is garbage collector crap. And this is why you don't see it in a Rust application. Check how clean that is. Question for you, Russell. I got some $8 computers. I got these. I got 1 second. Go to store. I got these. So I got these. The $8 128 megabytes. Now what the question is. I know, I'm a big spender. What I wanted to do, and I know I think I bought 6 of these without a fully fleshed out idea. But what I would like to do is I would like to make a few videos on a topic, like hacking around in assembly, and then post a challenge to get people involved where they can win a free one of these. I know it's $8, but like it makes it feel better if you do something, if there's like a reward at the end. And I know it's $8. I can't afford much more than that. Well, because shipping is gonna screw me. Actually, I probably should have like instead of getting 6 of these, I probably should have gotten like 3 of the other ones that are like better computers. I think these are really cool though because like I think they're gonna be really easy to power some lights and stuff with. I actually am pretty excited about these myself. You have a 64-bit RISC processor, and then you have two 32-bit RISC processors on these bad boys. I'm pretty excited. But I think these are pretty cool. I want to do something like that to get a little bit of community involvement as well as just to, but I don't know exactly what it's going to be. Like, I don't know what the challenge should be, but it should be fun. Anyways, food for thought. Food for thought. They even speak Wi-Fi. Yeah. Then they have USB. They have micro SD card slot. They have for more memory. Um, they have Zigbee, Bluetooth 5.0, um, 802.11, 2.4 gigahertz Wi-Fi. They have both USB-C and USB micro. And the Ethernet is like a hat that you have to put on. Like they don't have all the ports there, but like it it's a fun little board, and that's where like I thought it would be fun to like do a video and then challenge people to do something to the like the first 3 that complete this challenge. To complete the challenge, you actually have to help us complete assembly line so that you can use it to deploy to it. And that was my problem. Was like every challenge I could think of was like something to do with this single board computer. But then you'd have to have the single board computer to complete the challenge. And if you had the single board computer already to complete the challenge, then you didn't need a single board computer. So why was you what was in it for you to get another crappy little single board computer? I don't know. I really didn't think it through really well before I bought them. I was like, oh, that's a great idea. I found something that's cheap enough that I could do this and drive a little bit of community engagement and maybe like get some people excited. And then I realized that like I didn't think it all the way through. So they just have to run a web server on a RISC-V VM. Just have them submit their code on GitHub. Many proof of work. So in the future, like next year, I think yeah, anyways, I'll have to think about it. It's something that yeah, I thought would be good for the community. I thought would could be fun. Um I actually am gonna solder up one of these days my second light panel, and I'm gonna power the new one by this instead of my ESP32 device. Um, I think that I'll be able to power this one with Rust. The ESP32 I can actually program with Rust, but it's a pain, and I actually think I bricked one of the ESP32s. This I should actually be able to program with Rust right out of the box, which I'm pretty excited about because then the whole system can be Rust. But I was thinking about that. Like, so maybe my 10th Learn Rust episode, like, there's a challenge for you to do, you know, something in Rust, and the first 5 people to submit a GitHub repo, I'll send one to. Okay, I like that idea. I like that idea. Yeah, they're pretty small with only 128 megabytes of flash. Um, they have 64 internal PS RAM and 728 kilobytes of internal SRAM. So, okay, so the first person to get an OCI complaint container runtime running on 128 megabytes of flash, I think deserves more than an $8 an $8 prize. Here you go. Here you go. You did months of work. Good job. We appreciate it. Here's your $8. Here's your $8. It's going to cost me $8 to ship these things to people. But I got them. I got them before I thought about it. Oh, actually that's probably the better way of doing it is not buying them ahead of time, not shipping them from me, and just buying them and sending them to the person. That's actually like so much smarter than what I'm doing. I thought about limiting it to Americans or Canadians. I think that sucks. I think that sucks. Um, I know technically, like, prize winnings are this whole big thing where it's like you can get like double the price. Like I could pay like $16 of taxes to import this into certain countries, which is just ridiculous because it's a prize. But the worst thing is like there's like forms and stuff to fill out. Now I can just shadow ship it and not. I mean, like it's an $8 thing. I don't think anybody's gonna get really touchy that I shipped somebody an $8 prize. That I think that's what I'm going to do, just because um, it's an $8 thing. Oh, test equipment. Oh, I like it. Okay, so I'm just shipping test equipment. Okay. Sweet. I'll go with that. Again, it's an $8 thing. Like I was gonna say that's awesome. You worked in shipping. It to me it's just a bummer because like it makes. I mean I'm gonna take it shipping this anyways. One way or another, but I'm getting a new Null Labs T-shirt, which I'm pretty excited about. I'm thinking about the first person to complete it will also get a T-shirt. It'll be fun. I don't know. I'm gonna have fun with it this year. We'll see. Um, Hopefully, I don't run afoul of too much shipping constraints. I'm gonna have some South American country after me for my $8 uh board that I ship down there. I know. I know. I don't know what it is either. That's actually the worst part. It's not even about paying it. It's about knowing actually how to do the shipping. But you know what that t-shirt is? It's packing material to protect the board. I mean, that's what it is. You can play this game. You got to protect that board when shipping it across seas, dude. That's AliExpress probably owes about $20 trillion for this duty. Well, that's what I'm saying. Like, I don't know that anybody's gonna go after me for my $8 boards. I don't. Uh, Maybe they will. And when they go after me, I'll finally know exactly how much I owe them, and I can just pay them. So, anyways, I'm gonna get off. But yeah, that's actually a really good idea to do it with the to do it with like, and maybe I'll do it. So I planned on these first 10 classes and then doing another set of 10 where we start to dive into more advanced ones. And maybe I'll do a section in review like challenge to like really challenge what they know and to put everything that we learned into an application. And the first, X people get a thing off of that they can run and play around with and whatnot. So, so you don't with these you don't actually have to run an embedded. This runs full Linux, dude. So you can just run Linux on this and run Rust on it. That's what I was thinking that it would be at 60 frames per day. It doesn't have a GPU. There is no UI to it, but it will run Linux. I don't know how well. So that was my like easy. I ran Rust with like a really stripped down Linux OS. I don't know if it's gonna work well, but that's what I'm gonna try. 60 frames per day. It is a pretty massive step to work with no STD. Not a massive step, it's a massive pain. Oh, shut up on the function naming. With that, I'm gonna go. Stupid. Fun, function, funk, funky. See y'all.